Completely factoring polynomials, part 2. Or actually, it's part 3, but it's the second set of examples. So here we have another third degree polynomial. Someone gave me a hint that one of the zeros is 5 plus 2i. So I'm going to use the fact that if one of the zeros is 5 plus 2i, because that's a complex number, I also get a 0 at 5 minus 2i. Okay, so now my options include graphing this and then determining, a couple of zeros for myself in the hopes of breaking it down, or using these to synthetically divide or do long division. I'm going to suggest turning them into factors. So x minus 5 minus 2i and x minus 5 plus 2i. Multiplying those out, doing one long division, and getting the remaining 0. Okay, so if I wanted to multiply these out, this is x minus 5 minus 2i plus 2i. So it's a sort of funky difference of two squares. So when I multiply it out, I'm going to get x minus 5 squared minus 4i squared. So I'm going to get x squared minus 10x plus 25 plus 4. So x squared minus 10x plus 29. And I'm going to do long division with that. X squared minus 10x plus 29 long division into x cubed minus 7x squared minus x plus 87. So I need to multiply by x. I get x cubed minus 10x squared plus 29x. Draw a line. Subtract. So I get 3x squared minus 30x plus 87. So I need plus 3. 3x squared minus 30x. 3 times 29, let's see, that's 27, regroup to 2. Draw a line, subtract, no remainder. So what I have is, this is my third factor. So the complete factorization. And my zeros, 5 plus 2i, 5 minus 2i, and negative 3. 3 zeros, 3 factors. Okay. Again, we have a polynomial, this time 4th degree. So we're looking for 4 zeros, 4 factors. It says one of the factors is x squared minus 6. Well, all of our factors have to be linear x's, so x to the first power. So this is an interesting factor. It's not really a factor. Well, it is a factor, but it's not a linear factor. If I want to use this hint, rather than typing that into my calculator and trying to get some hints of my own, I'm going to have to do long division again. So x squared minus 6, x to the 4th minus 2x to the 3rd minus 3x squared plus 12x minus 18. Again, if I could factor that just by looking at it and grouping it somehow, I should, but I can't. X squared, so I get x to the 4th minus 6x squared. Draw a line and subtract. Negative 2x to the 3rd plus 3x squared, bring down my 12x. So minus 2x. So minus 2x to the 3rd plus 12x. Draw a line and subtract. 3x squared minus 18 plus 3. So 3x squared minus 18, draw a line, subtract, no remainder. Okay, so now essentially what's happened is this polynomial has become x squared minus 6 times x squared minus 2x plus 3. Now that's not what I'm looking for. I'm looking for 4 linear factors. So if you're really like quick on your feet, this would be x and x plus the square root of 6 minus the square root of 6. Because what we learned in this chapter is a difference of two squares, every number is a square. Because if you take the square root of it and square it, it becomes itself. This, wow, if that were a negative 3, I would be golden. But it's a positive 3. So I think I need to do quadratic formula again. Oh, darn it all. Opposite b plus or minus square root b squared minus 4ac all over 2a, 2 plus or minus the square root of negative 8 over 2, 2 plus or minus 2 root 2I over 2. So I'm going to factor out a 2 and cancel it with the 2 in the denominator and get 1 plus or minus root 2I. Okay, so I've got my zeros. I've got my negative root 6, my positive root 6, my 1 plus root 2I, and my 1 minus root 2I. So my complete factorization, I think I should change colors here. X plus root 6, x minus root 6, x minus 1 minus root 2I, x minus 1 plus root 2I. Phew, 4 factors. Okay. Okay, so now we have a 5th degree polynomial. So we're looking for 5 zeros, 5 linear factors. No hints. Now, these numbers look like I could somehow do some grouping with them, and maybe I could, but I'm going to bring up my graph. I've already typed this in, and when I hit graph, it draws the graph, and I see this. It looks like a cubic, yeah. Not at 1, but maybe at 2, because this is 2. I could again do calculate a 0 to see that there legit is a 0 at 2. But I'm going to try 2 as my 0. And since it was a cubic look coming through there, I'm going to try and see if it's 3 of my zeros. Now I'm not sure about this yet, so I'm going to put little question marks here. But given how even all of those coefficients are, I'm feeling pretty good about 2. So 1 and negative 8, 28 and negative 56, 64 and negative 32. So 1, 2, negative 6, negative 12, 16, 32, negative 24, negative 48, 6, 16, 32, 0. So one of them is good. And I did see that cubic look, so I'm going to try and layer in another 2. Now, I could have, If I had seen it crossing a 2 and a 3, I could have layered in a 2 and then a 3 and then a 4. It doesn't have to be a multiple 0 for this layering look. Okay, 1 and 2, -4, -8, 8, 16, -8, -16. Another one actually gives a 0 remainder. I'm going to go one more time. Again, if I had different zeros out here, I could be trying all different things, but I've got a lot of 2's. 1, 2, -2, -4, 4, 8, 0. So all three of them gave a 0 remainder. So now I'm only looking for 2 more zeros. This went from 5th degree. This would have been a 4th degree, a 3rd degree. This is a 2nd degree. So now this is x squared minus 2x plus 4. Again, I'm back to the quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a, 2 plus or minus square root of -12 over 2, 2 plus or minus 2 root 3I over 2. Again, I can factor out a 2 and cancel it with the denominator, so 1 plus or minus root 3I, 1 plus root 3I, 1 minus root 3I. Those are my zeros. So my complete factorization looks like x minus 2, x minus 2, x minus 2, x minus 1 minus root 3I, x minus 1 plus root 3I. My complete factorization. Okay, good luck.